Hi, welcome to this online-only CocoaHeadsNL meetup. For the people that are new to CocoaHeadsNL, we are a monthly meetup group for Apple developers. We are part of the international CocoaHeads and talk about anything Apple related. First of all, we'd like to thank our regular sponsors. They make it possible for us to host our meetups and to record and stream them as well. We would also like to point you to our apparel shop at cocoaheads.nl/shop. If you buy any of these products, you help us to host these meetups. Today, we will be giving away 2 JetBrains licenses for any of their products. If you win, you get to choose for which product. The license is valid for a full year. You can enter the raffle by simply entering the Meetups channel on the CocoaHeadsNL Slack at cocoaheadsnl.slack.com. If you don't have access to that yet, you can use this invite link. The first talk this evening will be from Jon Reid about real refactoring. He will demonstrate changing an iOS view controller from MVC to MVVM using small and verified steps. The second talk is from Jeroen Leenarts about Centraal Beheer and their path to microframeworks. We hope you will enjoy these talks. Please keep an eye on our Meetup page and our social media channels for updates on our next Meetup. If you don't want to miss any of our videos, please subscribe to our YouTube channel. It's the easiest way to see every video that we publish. But we also have our own tvOS app where we will publish every video. We hope everyone stays safe and healthy. Now over to Jon.
Hello, everybody. My name is Jon Reid, and I'm coming to you from my home in San Jose, California. I was originally supposed to give this talk back in March when I was in Amsterdam, and it's really too bad that COVID came and hit, disrupted the meetup, and I had to hop a plane and get out of there and get back to the US, which is too bad. I'd like to come someday again to meet the folks that I never got a chance to meet. I did meet some of you in the companies that brought me out in January and March to do teaching and coaching. Someday again, right? In the meantime, here we are. This is a recording. This is not live, but a couple reasons for that. One is that I wanted to remove any possibility of network problems transmitting from California all the way to the Netherlands. That's one thing. And another thing is that this gives me a chance to actually interact in the chats and deal with your questions live. So I'm over in the chat section right now. See? So I'm around to answer questions and interact with your comments as we go and talk about refactoring, which is what I am here to talk about. Oh, I forgot. Let's start with a book plug. My book, iOS Unit Testing by Example, is finally done and available. Real briefly, the book is in 3 parts. Part 1 deals with XE-test basics, and there's some subtleties around unit testing that you may not have thought of. And so that's part 1. Part 2 deals with iOS testing tips and techniques. So that's, the nitty-gritty. How do you test something in iOS? You might think that would be the end of the book right there. But actually, there's a part 3. And part 3 is almost entirely about refactoring. Why is that? I think that refactoring is one of the most important disciplines in terms of being able to be agile, to do agile software delivery. And there's a lot of confusion about it in the software industry as a whole. Folks say, I'm going to go refactor this thing, and actually they're just changing stuff around, or they're actually changing the behavior. Refactoring comes from this book. Where is it? There it is. by Martin Fowler. The subtitle is Improving the Design of Existing Code. And it's very important that it's about not changing the behavior. It's changing the code without changing the behavior. I'm not going to get into the details of the book. In my book, I reference specific examples from this, specific named refactorings, and go into a lot of detail. We're not going to do that today. Don't have time. Let's get into our example. For my example, in my background, I used to work at eBay. And I don't know about now, but back then there were regular items and there were sale items. Let's show you, and these are actual items that did sell on eBay at one point. For a regular item example, we have cornflake shaped like the state of Illinois. Illinois is a state in the center of the United States. This is where Chicago would be, and this is a small dime, 10 cents. For contrast, or for size example, and it sold for this ridiculous price. This is a regular item. A sale item would be like we have, 200 watches, and they're all going to be on special sale, limited time, and a discount. And for that, it would do something more like, well, it wasn't a Dorito shaped like the Pope's hat. This did sell on eBay for over €1,000, but it would be something like this, where we would have a title, an image, the original price with a strike through in it so that it entices you to say, whoa, look at that discount. I can get it for only €1,012. Fantastic. And a clear button. So anyway, this is what I'm going to refactor. We're not going to finish it, but let's start it. Over in the view controller, you'll see we have a few outlets: title, image, current price, strike-through price. And all these are set based on a property, the item, which is set from the outside to say, show this item, basically. And it has a did set responder and surprisingly complex in here. There's a lot going on. And I took this actual idea of code from actual code that had a lot more complexity to it. But if the item is nil, then it does this bottom part in the else of just setting various properties in the outlets to nil. Otherwise, we're up here where it's like, well, if there is an item, then we set the title, we set the image, we set the current price. But then things change around whether or not it's a sale item. It's on sale if there is a savings rate greater than 0. And if so, we set a strike-through text. I just slapped currency in here. Don't ever do that for real. This is just a quick example. Use actual currency conversion. But anyway, it sets the strike-through text, and it determines whether or not that strike-through price label is hidden or not. Okay? All this is covered by some tests. Let me give the tests a run. I am using app code. App code is really more powerful than Xcode in terms of its refactoring abilities. I also prefer it for running tests. You can see if you want to look at it. Oh, you can play with this on your own, by the way. I'll put the code up. You can see the 10 tests that we have and the various things that it examines. But let's start. What I want to do is start pulling this nasty mess out into a view model. In my book, I take a different example and we do model view presenter and then model view model. But here, let's just do MVVM. So to start with, what I want you to keep track of while I do this in the short time that remains is how many times I run tests, okay? So the first run was just to see that we're green. Refactoring, you should always start in green and end in green and not go through red. So what we want, let me back up. What we want is when the item is set, we're not going to change this interface because we don't want to touch it from the out, change how other things interact with it. When this is set, we want it to jam this into a view model. Let me first make a view model out here. Private. And we'll call it item view model. And it doesn't exist. We have a choice of where to create it. I'm going to, instead of putting it in a different file, which I normally would, I'm just going to keep it in this file just for simplicity of this presentation. We'll make it a struct. Let's make it private. And let's see if this, did I break it? Does this still work? And the answer is I did break things. Let's fix that. The view model is going to be that. Okay, so we've run tests now, or tried to run tests before. It failed with a compilation failure. Here we are. We're back to green. So you might dip into red for refactoring, but get out as soon as you can. All right. Now we want to move some stuff over. What we want is to say, when the item is set, let's actually set that on the view model. So we say viewModel.item equals item. This doesn't exist. That's okay. We'll make it exist. And this will be, what is, oh, yeah, item. Does this still build? Sometimes I don't know. Seems to be working. All right. So when the item is set, it's going to set it, set on the view controller. It's going to just pass it right to the view model. And then we want to get these other things from the view model. Let's start with the title label. A basic pattern of refactoring that comes throughout the book in every refactoring example is to a pattern that some call expand, shift, and contract. What we do is I think of it in terms of we lay down the new thing, even though nothing is calling it yet. And then we start shifting stuff to call the new thing. And then we get rid of the old thing and we clean it up. So let's do that. I want to essentially set this title label text from the view model. This is a optional string. So let's add a property, a computed property. Call it title. And we'll just see if this still compiles. In case anything is angry. Apparently fine. Now, what I'm going to do is I'm going to lay down the new stuff by copying all of this and slapping it in here and getting rid of anything that's not related to title. So everything from here on down and here on down. And then instead of setting title label, we're going to return this or that. I don't really need to run tests. I just should build to see. That's part of the process. This counts. If you're keeping count of how many times I'm doing this, that counts. That builds. So now let's try to shift this over one at a time. Instead of setting it the title label text from the item title, let's set it from the view model title and see if this works by running tests. Okay, that's successful. And then down here, same thing. Run tests again. Success. So now we can do some refactoring. Well, I am refactoring, but we can do some cleaning up of the change we've made. Now the work is being done in the view model, but we have duplication between here and here. So we can pull this up and out of the conditional. This is another refactoring pattern, is to take two parts that look different and make them the same so that you can get rid of the conditional. And let's run tests again. Okay. So that cleans up the did set in here. Now let's clean up the stuff in here. This can be simpler because instead of having the conditional, we can say, well, return the item title. App code handily adds the conditional there. Let's just sort of comment that out in case we made a mistake. This is also a technique I use, is like, let's just try for a bit to see if it comes back, and or to see if we need to get the old code back. Let's just comment it out for temporarily. So let's run tests. Okay, it's good. So I can get rid of that. And then app code is suggesting already by the fact that the return is grayed out that it's redundant. So I can say remove the redundant return. Let's join these and do some reformatting to simplify it. Great. We moved one thing from the view controller into the view model. We can do this again. Let's see, what's next? So we're doing title label. Image view. Image is an optional UI image, so let's create that. We'll call it image, which is an optional UI image that returns nil. And this counts. Remember, I'm building. You don't always have to run tests if you just do the first part of laying down the new thing that nothing is calling yet. Now, once again, going to copy the old code, slap it into the new place, get rid of anything unrelated to the image view. Oops. Change it to return the values instead of trying to set something. See if this builds. Okay. And then we can now we've expand, shift, contract. We've put down the new thing. Now we're going to shift each caller one by one from the old thing to the new thing, and then that should leave us in a good state. So item view dot image, instead of item image, this is going to be the view model image run tests. Shift and run tests. Here we go. Same thing here. View model dot image, shift, and run tests. And then now we've taken these two lines that were different and we've made them the same. So now we can pull it out of the conditional and run tests. You starting to get the idea here? And that cleans up the did set. You see, this is starting to shrink in here. Okay, this still has this complexity. We can do the same thing that we did before, which is to say, return the item dot image and have app code handily add the question mark there. I'm going to be a little bolder and get rid of this. I'm a lot more confident that this is just going to work. Run tests. And now that it's down to a one-liner, we can get rid of the return, join it, fix up the formatting, and run tests again. I think we have time for one more. Let's do one more. I'm not going to be able to finish the whole thing, but let's now do the current price label, because this is going to be a little different from the other ones. The text here is an optional string. So this will be var current price. Build. Okay. And now let's do the same trick. I'm going to copy that whole block, slap it in here, get rid of anything that's not dealing with current price. We've seen this now a few times, but it's going to end up a little different this time. See if this builds. So we've laid down the new thing, but I want to make sure it still builds, because sometimes it's like I need to, change something in the initializer. Okay, so now we can say this is going to be view model current price run tests. Good. And this also view model current price run tests. Cool. And now to clean this up, again, these are the same. So I'm going to pull this out, get rid of this, run tests. You see how did set is the conditional part is shrinking. And now we get Swifty and say, well, this is a little different from these other cases because it's converting the current price into this thing by prepending the currency in a bad way. Like I said, don't actually do this in production code. You don't use NS currency, whatever it is. And this is where, if you are a smarter person than I am, which you probably are, you can probably write out the functional code right away. In fact, maybe you could have done all of this in one step. And that is the strong temptation by lots of people, is to make all sorts of changes in one giant step and see at the very end if it still works. The advantage of working in small verified steps is I take a step and I see if it works. And if it doesn't work, I revert. The other advantage is that I can commit this to the main branch. I can push it up and into production code without disrupting anybody, because I know everything still works. Anyway, let's come back here and finish up this example. We want to say, take the current price, which may or may not exist, and I only know this because I've tried this. Okay, so we want to map a decimal into something else. So we can do that with a transform where we say, and now I'll take this string, replace that with that. I think this is correct. As I was saying, you're probably smarter than I am, and you can do this in one step. I'm not as bright, but I don't have to be, and neither do your coworkers. We can say, okay, this old code, it works, but there's a much cleaner way to express it in Swift using functional programming. And we can get there incrementally by making it work and then cleaning it up and separating those things So you don't have to be a super perfect Swift programmer. I'm not. I rely on the tests to tell me whether or not what I've done works or not. So let's also get rid of the return here and change this into a one-liner. And this will be the last thing that we do. All right. Let me wrap up. Some things about what I've shown you. First, let me summarize some things. In order to do this kind of refactoring, you need tests. Now, what do you do if your code doesn't have tests? Well, then you'll need to add tests. But sometimes in order to add tests, you need to do refactoring to make it testable. Then what do? The answer is then you rely on manual testing, and that's okay. You pay the price for that because you don't want to keep doing that every time. You're making it testable so that you can, you're making it testable so that you can add unit tests so that you don't have to do it manually every time. Another thing is it's super essential to have fast turnaround time for this kind of workflow. You may have looked at this and thought, there's no way my code builds and runs tests that fast. Couple ways to deal with this. One is sort of the short-term solution is to say, well, then I'm not going to run tests every step. I'm going to aggregate steps. I'm going to take a step, take a step, take a step, take a step, and then run tests. Okay, so that's the quick pragmatic solution of what to do. The larger problem and challenge to you is, well, then reduce that time. Find ways to break it down. Suggestion is don't build your whole app. Work only in part of your app by breaking your app into smaller frameworks or libraries so that you can test each thing without building your whole freaking app. And I think that's my nice segue, hopefully, into Jeroen's talk. Finally, to repeat what I tried to say is that the general meta pattern of refactoring is lay down a new thing, make sure it builds, switch things over one at a time, or if you can do it in a global search and replace, that's fine. But switch things over and make sure the tests pass. And then get rid of the old thing if it's still hanging around. And that is the essential nuts and bolts of refactoring done properly and what I wanted to show to you. Before I hand off to Jeroen, one final reminder. This is available, iOS unit testing by example. All right. Thank you very much. And I hope this was interesting and useful. And I really hope that I get to come back to Amsterdam and hang out with you folks. All right.
Hi, my name is Jeroen Leenarts. I work at Centraal Beheer, which is a brand of Achmea, and I will talk to you about our path to microframeworks with Toist.io. First, a little bit about me. I've been a software developer since 2002. I've been doing iOS development since SDK 3, and I've worked on several small and big business-to-consumer and business-to-business apps, amongst them ING Banking, Neon, Achmea, and SurfNet and various other apps. I'm also available for hire on my brand AppForce One. So if you have a task that you need fixing for iOS development, just let me know, get in touch, and I'll see what I can do. I'm also the chairman of CocoaHeadsNL. So if you want to present at one of our meetups, just get in touch with me, Bart, Yolanda, or Marco, and we'll make sure to set you up for one of our future evenings so that you can actually present to our community. As I've already mentioned, I'm also employed by Achmea. So build times increase. Who owns what code? These are problems that you run into if you have an iOS project in Xcode that is getting bigger and bigger. I don't know what build times your guys are dealing with, but at Centraal Beheer, at some point it was like 5 minutes, and it was really becoming a problem for our unit testing workflow. And also it's just a pain in the you know where to actually just compile your project from scratch, that it'll take 5 minutes, and what do you do with that time? Also, because of the structure of our code, everything was in one big target, it gets harder and harder to keep that well structured and to have a good idea of who owns what code and who's mainly responsible for what code. Of course, everybody is responsible for all the code, but people do tend to have their own focus areas that are based on the team that you're in. So we've looked at some different options to deal with the project complexity. We've looked at Bug, Bazel, Toist, and manual. The last option is actually what we started with. We started generating manual frameworks ourselves and just try and see what actually it can bring to us. And we've noticed that it does bring a lot of benefits, but it's hard work manually creating frameworks in Xcode and making sure that it keeps working, and it's very error prone, and it's something that we didn't want to keep on doing into the future. I can go into a lot of details about Bug and Bazel, but suffice to say that Bug and Bazel add a lot of complexity to your project with tooling that is very unfamiliar to iOS developers. And when we started looking at Toist, it felt way more at home and more convenient, and also much better to understand if you are coming from an iOS or Xcode-based development workflow as a background. So Toist, we've went with Toist. We started experimenting, and since 2 weeks, I think, right now, we're actually transferred our entire project from our old approach, which was manual dependency management with CocoaPods, to using Toist. So what is Toist? Toist is a command line tool that aims to facilitate the generation, maintenance, and interaction with Xcode projects. Toist itself is written in Swift, but also the manifests that you have to maintain for Toist are actually also written in Swift. I think it's just best to show you what it is about. So open my terminal. Let's see, what should I show first? Let's just show our project first. So what I do now is run our command line tool Toist. I run Toist edit, and what it actually does, it inspects my folder structure, and it generates an Xcode project only containing the manifest files of our project. So we have a workspace, several projects, and sort of like a base folder with several manual files you can add there that allows you to configure and create some sort of convenience classes that help you generate your project structure. So in our workspace, we define what projects we actually have. And in one of our projects, let's pick a convenient one, we actually define that we have a project. It is a framework. It's named Even Apple Common. It's targeted at iOS. It has a resources folder, and it has one single dependency. Very easy. Let's look at another. Let's look at the core. It's a bit more complicated. Still very good to get a grip on. So it's basically the same stuff. It's a framework. It has a name. It targets iOS. It has some resources. Then it has a number of dependencies: common, domain, network, assembly, and UI. I'm mentioning resources here, but what about my source code? Well, let's go into a little bit of detail there. This is into our project templates, which are located here. And here you can actually see that the framework function that we've seen earlier, it's a bit more involved, and it has a number of default parameters. For example, if you look at, where is it? The resource that we pass in, that's actually an empty array. But we actually, if we call it, we add a resources declaration, and then the resources are available. The sources they're actually, if you look at the framework, it links through to project, and then in project we have a number of targets, and then we have sources here. There's something interesting going on here. So let's just go into Xcode with our project and see how this stuff actually maps onto each other, because I've just given a quick view into the details of Toist, but now just let's get an idea of how this looks into our project. Takes a while to generate, approximately 10 or 12 seconds. And then once it's done, we have a project. There we are. We have a project here, so let's see. This is not too bad. Let's look at the initial example that we looked at, the common one. So you again see projects and common. And well, we have sources, we have resources, we have tests actually. And this project actually has targets. You see a target A common, a target A Apple common tests. Let's look into what we have here. So if you look at Ava Apple Common, you see it's a framework. It's called Ava Apple Common. We link through. Then we see the framework links to a function project. This project has 1, 2 targets. It has more targets if it's an app. And then what you see here is that the name of the test target, which is defined here, product unit test, is actually the name of the project with tests appended. So if we pass in an argument with the name string, Ava Apple Common, and product is called Ava Appen, and the test targets is called Ava Appen tests, which is right what we see here. As you notice, my Xcode is happily indexing our source code, and considering the amount of CPU that we're using, you can actually get a good idea of how much code our project is. Well, maybe just I should show that. This is only the source code that we authored ourselves, so this is no third-party dependencies, nothing CocoaPods, no Swift packages. As you can see, it's a lot of files. And we're waiting for a bit because Xcode is eating all my CPU actually. There we go. So it's a project with close to 160,000 lines of Swift code and 21,500 lines of Objective-C code, and then some other smaller bits and pieces and a bunch of XML, which is not very important, because of course the XML, that's the zip files and the storyboards and stuff like that. So all in all, it's a reasonably sized project. So we have two targets, common and tests, which is as declared here. And this is your main target, and this is your tests target. So what you see actually is with Toist, you actually generate a number of projects. You declare them in Swift, and they actually result in something that is in your Xcode navigator. So what does this mean about the Xcode projects themselves? Do you have to add them to source control or not? Well, we chose not to add them to source control because we generate them fresh each and every time. So now I've shown a few basics, and now we can go into a bit more details. So back to my slides. What I wanted to show, this is the situation that we had before we switched to using Toist. So you can imagine all those lines of code, they are somewhere in this graph. And basically most of them were in this little blue box at the top here, so it's not really to scale the blue box. It's actually, compared to the other stuff, it's way bigger. And that's also one of the things that we wanted to fix. So once we were done with our initial migration from Eva app to Toist, this is the graph that we ended up with. So you might imagine, let's look at the first one. Why is this worse than this? Well, basically what you get here is that related code is now in close proximity to each other, and it's very explicit where you need to look into your source tree. So for instance, if you want to look at networking related code, we have our networking project, and we have a number of network jobs and some convenience deserialization helpers, and mainly the gist of our network. We also use an API gateway type layer, which is called SAP Mobile Platform, and to actually unlock everything that's in there, we have a lot of code to actually deal with the complexities of that as well, which is this. So basically what this means from the network perspective, we have to use our API gateway, but all the internal complexities related to that, they are in here, and we're only talking to an API that is publicly exposed to the rest of the world by this S&P framework at the bottom here. So I say exposed, because we are working with frameworks, there is one very convenient feature of Objective-C that is now actually meaningful, and that is actually, if you look at something innocent like a formatter, if I would remove this public statement, then this function would only be visible within this framework, so it would not be exposed outside of the Eva App Common framework. So that means that if you write like convenience or helper extensions or functions, you can just create those. You don't want to bother the rest of your teams with it, so you don't declare it public. Everybody within your framework can actually use it, but nobody else is actually bothered by it, so you don't get any namespace pollution, or that you actually by accident override somebody else's convenient function because you happen to just import their stuff on top of your implementation. So to go into a lot of to continue on with Toist, what I've already showed, you can now declaratively create your project. Of course, Toist has a lot of documentation on what is actually available. It's actually quite good documentation to just read through and just come to grips with what is there. And what they actually provide on this project description, this is the main thing that you can split with your description helpers, is that you can see here a project has targets, a target has schemes, and everything just bolts and fits together in a way that actually an Xcode project is laid out as well. And that's actually very interesting to see, because once you start working with Toist and actually understand the model that Toist is providing to you as a software developer, you actually notice, hey, but this is of course very similar to what Xcode does, and then you notice that it's somewhat of an abstraction to what Xcode does, and you get a better understanding of what's actually going on within Xcode as well. Of course, there's some other cool tricks as well. You can focus on a specific area. So I can actually, if I work in my project, I can actually say, well, I just want to work on the common framework, which is this one. I want to unit test it, and I'm running my unit test now. It doesn't have a lot of unit tests, I think, this one, not yet. And you've seen it actually compile quite quickly. And now it's running the tests. basically waiting for the simulator to start is something that we're all a bit too used to. And the unit test is already finished. So what you gain with this is that you can only like zoom into the area that you want to test, and it's actually very quickly to actually compile, launch, and test that. So you get back that really short feedback loop that you want to have when you're unit testing, and that's one of the biggest benefits that we're getting from Tourist at the moment. Also, it integrates well with our Azure pipeline environment. So just to give you a little bit of an insight into that, we have our pipeline definitions, a lot of stuff going on here. But basically, at the start of our pipeline, what we need to do is just make sure that we run our Tourist generate script, and then our projects are generated, and then everything is as it used to be. So you have a project and you can just continue doing your build on your infrastructure. So basically, I've given you a brief insight into what Tourist can offer. I imagine there are a lot of questions, and I don't know what the specific questions will be, but I'd say just ask away, and I've actually taken a little bit less time on my presentation, so I have more time to actually answer my questions. Thank you.
Zo. Ja, is er geluid? Okay, so there was a question by Axel, I think, about how do you know what your main target is? Well, that's something that you know yourself. In our case, it's just Even Appen. You can recognize that in your Tourist project file by that being the project that has no targets pointing towards it. And people hear typing, it seems. And so yeah, it's something that you just have to know, Axel. Other questions? Well, there was a good tip by Dasdom actually. If you open the target selector, then you can actually You can actually, by typing, select your target, so it's easier to pick your targets. Also, something that let's see, that Jon Reid, that he mentioned that is that if you use Tourist, you have small projects, and indeed, if you look at the smaller projects, your compile times, they are a lot less than if you compile and test your entire project. And that's one of the biggest advantages of using Tourist in my mind, because you can just really shorten the feedback loop that you're dealing with when you run your compile and test loop. Any other questions? With Vapor, Xcode defaults to some vague library. Okay, I don't know Vapor that well, but I believe you, Axel. Let's see if there's any questions in Slack. Okay, so I'm not seeing any questions in Slack. Any questions in YouTube remaining? Let's scroll down. Oh yes, Jon, that's actually included in the package. You just run Tourist space graph, and you've seen the images in my presentation. Those were actually generated with Tourist, and it uses a dot format internally. So you can actually output it as a point dot file, so that's Graphis, or you can output it directly to PNG, so that you can immediately include it in your documentation or share with your team. Can Tourist convert your projects to their templates? Well, that's a question by Marius. Can Tourist convert your project to their templates? That's one of the biggest hurdles, actually, because you have to take the pain of actually converting your entire project to use Tourist, because it's a different format, and you have to take your time to actually do it. What we did at Achmea is actually we wrote a make file that moves all the files into the correct positions, and then you have to, of course, do a lot of small tweaks to your code base to actually make it work. And we stored those in a Git batch file, so that every time we updated our development branch, we could actually run those two things fresh and see where we were at with the Tourist migration. So then the rest of the team could keep on working with what they were doing. And that actually allowed us to keep working and actually do the migration simultaneously. And once we were ready, we ran the scripts, committed everything, and then just hoped for the best, really. And it worked out. I'll ramp up. A question by John Nyquist. What was your team's ramp up time to start using Tourist? The technical migration, I worked on that for 6 weeks on and off. So it was like an off time project for me. So I spent like over a period of 6 weeks, I spent like maybe 8 hours each week. And then once we migrated, the entire team really, they just picked it up in a matter of like 1 hour of hands-on training with 8 people. Marius asks if you need to start from scratch, even for an existing project. Well, basically, you just drop your Xcode projects and your workspace files, and you make a new project structure. So yes, project-wise, you start from scratch, but of course, you hang on to your source files and your resources. Any other questions? Okay, I'm reading. I saw that you have dependencies integrated with pods and Swift Package Manager. That seems great. Any limitations on that or troubles with mixing dependencies? Can you also specify manual dependencies or cartridge? That's a question by Plamen. I hope I pronounced it correct. Plamen Andre. He has a question on dependency management within Tourist. Yes, within Tourist you can use CocoaPods, cartridge packages. You can use Swift Package Manager. You can use just your regular old .a file with headers, or just if you have some sort of dynamic or static framework lying around, you can also include that. One thing that you have to acknowledge is that Tourist at the moment doesn't have full support for CocoaPods. It's not a problem, but what it means is that you basically have to make sure that you generate everything, your entire project structure with Toist, which is based on Swift packages, cartridge, and everything else. And then that structure, you actually, as an afterthought, you run CocoaPods on that. So you have to have intimate knowledge of your targets, which is, of course, that's something you have. And then it just works out of the box. And I do know that the dependencies, we don't have dependencies within Swift Package Manager that depend on anything in another package manager. So that's, of course, something, if you have an interdependency between dependencies, they, of course, due to the nature of the tools that you're using, the dependencies of your dependency would also be automatically included already by the by the package manager that you're already using. I don't even know what I said right now, but I hope it makes sense. So, and Plamen, if you have any other questions on that, or if you want me to showcase some stuff or talk through you some things with that, just ping me on our CocoaHeadsNL Slack, and I'll see if I can help you there. And Axel has a question based. Well, Axel is enjoying his love for Vapor, it seems. Any other questions? No, Axel is wondering actually if Toist is doing it better than Vapor. I don't know. I don't have any experience with Vapor Xcode. This is so weird. I'm seeing myself delayed with like 30 seconds. Okay, there's no more questions. People on my screen are waving at me to put an end to this. And I hope you enjoyed my talk. It was kind of a new experience for me to actually do something pre-recorded. I work way better in person when I'm presenting, but I hope my talk made sense. And if there's any questions that you have, then just ping me on Slack or on Twitter or whatever, you can reach me. And also make sure to join our next CocoaHeadsNL meetup. Thank you very much.